tonight's lesson is on Venn diagrams. So you might have seen Venn diagrams before. They're used a lot of times in science to kind of give a picture representation of things. And before we get into the lesson, we do need to talk about a few things. The main thing I want to talk to you about is the difference between an and an or. So if it is an and, it's a very exclusive circle. So you must be, let me write must up in top, real big. So you must be in both groups. Okay, and I'm going to write down here exclusive. So an and is very exclusive, not many people. In or, you're in one group, the other group, or both. So again, it's more inclusive. It allows more people. So let's go ahead and start. Shade the area represented by each statement. People who like rabbits, but not fish. So first of all, do you see that you've got this blue circle of fish? You have this pink circle of birds. And how about we do a green circle? Hopefully you guys can see the green of rabbits. Okay, so we need to be in the green rabbit circle, but not the blue fish circle. So anytime it says but not, I kind of use my finger and cover it up. Okay, so I want to be with the rabbits, but not the fish. So do you agree that I could be here? The question is, what about these people? Should I shade them? Do they like rabbits but not fish? Yeah, they do. They like birds, but I didn't say they couldn't like birds. Okay? So let's try the next one. People who like fish and, so I'm going to highlight that this is an and, birds, but not rabbits. So again, I'm excluding the rabbits. Okay? So I'm going to cover up rabbits totally. Now, I need to check this connector. Is it an and or an or? It's an and it says up here that an and must be in both groups. So you have to be both in the fish group and the bird group. So you're this little section right here. Again, if it helps you to, highlight your circles and give them color, if that helps kind of clue your eye, you can do that. Again, it's up to you. You don't have to. But if it's helpful, go ahead and do it. Alright, let's try number 3. So I'm going to go ahead and highlight my circles real quick. Alright, let's read what we're supposed to do. Shade people who like fish and rabbits. So again, I have that and connector. Does it say to exclude anybody? No. So I'm not going to cover anybody up this time. So the fish circle is blue and the rabbit circle is green. So I need to shade where the green and the blue overlap. So let's see, the green and the blue overlap here and here. So I'm going to shade that whole region. Okay? Alright. If you need to, go ahead and do your circles. People who like fish or, so a different connector this time, birds, but not. Alright, so again, I'm excluding rabbits. So that means you have to use your finger and cover up rabbits. Now let's look. Our connector is an or. And the or says you can be in the fish group or the bird group or both groups. So again, much more inclusive. We're going to shade the fish group that I can see, the bird group, or both. Whoops, sorry about that. People who like only fish. Alright, so you can only be in the fish circle. You cannot like birds, you cannot like rabbits. I want you to think about what you would shade. So I'm hoping you shaded, or you thought about shading, just this little sliver here. I can't shade here because they like birds. I can't shade here because they like rabbits. And I can't shade here because they like everything. Alright, number 6. If you need to use your colors, use your colors. Alright, people who like birds or fish. So, I'm not excluding anybody, and my connector is an or. So this time you have to be in the bird circle. So the bird circle's pink, so I'm going to shade everybody in the bird circle because I'm not leaving anybody out. Or fish, so I need to go ahead and shade everybody over here in the fish circle. And that's my shading. Okay, now in the next section we're going to be asked to draw some Venn diagrams to match conditions. So off to the side, I need you to draw these 3 pictures.
Sam, please come to the front office. Joseph, Sam.
Alright, so the first circle inside a circle is when you have the words all. This represents some. This represents none or no. Now, they're circles. They can be any shape you want them to be. They could be squares, they could be rectangles, hexagons, whatever you wanted them to be. Alright, so what you're going to do is you're going to start with the first statement and work your way out. So it says, all kittens are cats. So we know we need a set inside of a circle. Now, you ask yourself, who is the smaller set? Who's the subset? Are all kittens cats or are all cats kittens? So kittens is a subset of cat. And we're going to abbreviate with a K and a C. Then it says, all cats are mammals. So again, the word all, I'm going to surround it with mammal. All dogs are mammals, but no dog is a cat. So I need to put dog in the mammal circle, but not touching the cat circle. So I can squeeze dog over here. If you'd like to, some people kind of line them out as they draw their stuff so they know they've accomplished everything. Now, number 8, I see this keyword, some. So I can draw my 2 circles interlocking because that's what some means. Some students sing and some students dance. All students, so all go to school. Alright, number 9 looks like a lot of fun. There's a lot of stuff there. So again, don't panic. Take it phrase by phrase. All counting numbers are integers. And I kind of made my counting bigger because I can see right here where it says all whole numbers are counting numbers. So all counting numbers are integers. All whole numbers are counting numbers. All integers are rational. No rational is irrational, so no means over here. You know what, guys, we need to fix something. This should say all whole numbers are integers, and all counting is whole. So this should be W and this should be C. That was bothering me because that's not the true statement there. A counting numbers like 1, 2, 3, 4, 5, a whole number adds in 0. Alright, so we got whole is integer, counting is whole, all integers are rational. We're here. No rational is irrational. All numbers are real. Now, if you want to change things up, you can put a box around it like that. Okay? Alright, moving along. Number 10. It now says to write the statement. So, start with your innermost and work your way out. So it says, since it's a circle and a circle, all squares are rhombi, plural of rhombus, and then this is surrounding, so all rhombi are quadrilaterals. I don't have to say that all squares are quadrilaterals because this tells me that they have to be nesting. Alright, number 11. Let's start with the innermost circle and work our way out. So how would you write your first statement? I hope you said all squares are rectangles. So that takes care of this circle. What about this? No triangle is a rectangle. And finally, how would you communicate this last thing? All triangles and rectangles are polygons. Okay? Alright, flip to the back of your sheet. So now we're going to answer some questions about these. So make sure you have your calculator, if you have one at home, something that you can do some adding on. Okay? And I'm going to go ahead and again use my colors. So I have Jell-O, pudding, and yogurt. And guys, I just realized that the mic was clear across the room. Well, not really. But anyway, so I apologize if the sound has been off a little bit, but hopefully it's been at least loud enough. We're going to run with it and see. Alrighty, so it says how many people like B. Again, watch your connectors. Is it an and or an or? So this is an and connector. So you have to be in the blue circle and the pink circle. No exclusion, so I don't cover anybody up. So where do blue and pink overlap? I think they overlap right here at 12 and 6. So I get 18. Now, number 13 is the same thing. Focus on the blue and the pink, but this is an or. So in or, you're either in the blue circle or the pink circle. Please don't double count, people. So in the blue circle, I've got a 33, an 11, a 6, a 12, and in the pink circle, I've already accounted for the 12 and the 6. I got, what, a 9 and a 37. So let's grab our calculators and see what that is. Alright, so it's 33, 11, 6, and I get 108 people. 14. How many people like Jell-O and yogurt, but, so I have a but, not pudding. So I have to cover up the pink circle. Now look at your connector. What is it? Your connector is an and. So an and is where the blue and the green overlap, which is just 11. How many people like pudding only? So you can only like pudding. You cannot like Jell-O. You cannot like yogurt. So you are only in the pink circle. I hope you said 37. How many people like Jell-O or yogurt or pudding? So you're in the blue circle, the pink circle, or the green. So you're going to add up every one of these numbers. And I think you get 133. Because up here we had already added the blue and the pink. I think we only have to add the 25 in. Now, let's talk about what this number is out here. What do you think that number represents? I'm hoping you said it's the people who don't like any of these three. And you're right. So when it says how many people were surveyed, you got to take into everybody who went into a category plus those 7 to get 140 people. Alright, how many people like Jell-O, pudding, and yogurt? So you have to like everything. You've got to be in the blue, the pink, and the green. So the blue, the pink, and the green meet at 6 because of the and. How many people like pudding, but not? So again, I have a rule. It can't be Jell-O. So I have to take Jell-O totally out. Who's in the pink? 37 and 9, which gives me 46. How many people do not like yogurt? So who's not in the green circle? Right? So ignore this, right? Who's there? So we have a 33, a 12, a 37, and these 7 people. Okay, so let's add that up. 33, 12, 37, and 7 is 89. Number 21. How many people did not like any of these desserts? I'm hoping you said 7. How many people like yogurt or pudding, but not Jell-O? Okay, so I'm going to cover up Jell-O, and it's an or. Can you please think about what you would write? The correct answer is 25, 9, and 37. Because it was an or. So you could be in one circle, the other circle, or both. How many people like yogurt and pudding, but not Jell-O? So the same question, but this time an and connector. What do you get? Number 24, how many people like Jell-O and pudding, so it's an and I throw in this word only, which means you can't like yogurt. It's the same way of saying a but question, okay? So it's Jell-O or pudding, Jell-O and pudding, but not yogurt. So an and would leave us 12. How many people like yogurt, but not pudding and Jell-O? So you can't like pudding or Jell-O, you just like yogurt would be 25. And finally, how many people like pudding and yogurt, but not Jell-O? I believe that's a repeat of a question, right? Because I take out Jell-O and it's an and connector, so it would just be 9. Okay? Down here, I'm going to have you copy down what is a biconditional, and that's where we'll end the video. And we'll go ahead and finish this up in class tomorrow. A biconditional statement uses the words if and only if. For a statement to be written as a biconditional, the statement and the converse must both be true. Okay, so we will finish up number 27 and part 4 tomorrow. And you guys have a good evening. Don't forget, take notes.